Welcome, folks. We're here to try and identify reduction and oxidation half reactions when we're given an unbalanced reaction, such as the one here between silver ions and zinc. So let's take a look at how we're going to do this. And remember, reduction is the gain of electrons, right? So reduction is gain and oxidation is a loss of electrons. So we need to identify how the electrons are moving. That's going to be the key here. So to help us do this, we take a little look at our reaction that we've got involved. I'm just going to color here, and you'll notice that zinc is going to start as zinc solid and finish as zinc 2 plus. So we know it's giving away the electrons, because to go from having no charge to a charge of 2 plus, it's got to lose electrons, get rid of some of the negative, right? So we know that electrons are moving to the silver. So silver is gaining the electrons, right? And we know that zinc's going to want to do too, but this isn't balanced reaction. And for identifying reduction and oxidation half reactions, we don't need it balanced at this point. We just need to know how the electrons are moving. So when we take a look at this, we can recognize that if silver ion is gaining them, remember that gaining electrons is reduction, a reduction half reaction, that's my short form for half reaction. So our reduction half reaction is going to involve the silver ion, and we know that this silver ion is going to gain an electron, and once it gains an electron, it becomes silver solid. So we've now got a scenario where that electron in this reaction is being added to the silver ion, and we create the silver solid. We've got a reduction half reaction, right? This reaction is showing the gain of an electron by the silver ion. If the silver is the thing that's being reduced because it gained the electrons, the zinc giving away the electrons is oxidized. Remember that little trick that we talked about? Leo says Gur, right? Leo the lion. So Leo says Gur, lose electrons, oxidation. So our oxidation half reaction is going to involve our zinc. So our zinc solid has to lose electrons. So we know that the electrons are going to be on the product side when it loses them, and we should be creating Zn2 plus. So now we just need to figure out, is our half reaction balanced with the number? Do we have the right number of electrons being transferred? So zinc, to get from 0 charge to 2 plus charge, wants to lose 2 electrons. So we're going to see 2 electrons in that half reaction. So this is how we can identify our half reactions for our reduction and our oxidation. The key is looking to figure out how those electrons move. Let's take a look at another example. In this example, we have cobalt reacting with MnO4 minus, and that's producing cobalt 2 plus and Mn2 plus. And again, we don't need to have a balanced overall equation to be able to identify what's being reduced and what's being oxidized. We have to follow the electrons. So I like to pick one of the two substances, and if I ever see one where there's a polyatomic ion like this, usually I ignore that first, and I deal with the other substance. I'm going to look at cobalt. I know that cobalt went from cobalt solid to cobalt 2 plus. So we're going from our cobalt solid to our cobalt 2 plus. So to do that, cobalt had to get rid of electrons. So I know that the cobalt here is giving electrons to this substance. Okay, so it's giving off electrons. So that helps me out, because if I know what the cobalt is doing and it's giving off electrons, remember that losing electrons is oxidation. So our oxidation half reaction needs to involve the cobalt. And we know that it's losing electrons. We'll worry about how many in just a second. And it's becoming cobalt 2 plus. So to go from no charge of our cobalt, right? So our cobalt here has no charge, to a charge of 2 plus, right? According to that ion, we know that's going to have to lose 2 electrons. Now, when we deal with our reduction half reaction, this is where things start to get a little bit trickier because of the polyatomic ion. We need to look at what happens to the manganese in the polyatomic ion to becoming manganese 2 plus. So our half reaction is going to involve manganese in the MnO4 minus, and we know it's got to gain electrons. So to gain our electrons, to be the reduction half reaction, and that will allow the manganese that's in this polyatomic ion to become Mn2 plus. So what we need to do is we need to figure out really what's the charge of the manganese in this polyatomic ion. And this is where it gets a little bit trickier. So I'm just going to switch colors over to a purple color here. So let's focus on the manganese. So that manganese is what we're trying to identify. So we're just going to work off to the side here. And we're going to use a little bit of knowledge that we have. We know that the charge of oxygen should be 2 minus. So I'm just going to write that above my oxygen here. I know that for oxygen, it should have a charge of 2 minus. And if there's 4 oxygens, that means in total, we're dealing with 8 negative coming from that oxygen that's in that particular polyatomic ions. So if we're dealing with 8 negatives, but I want my overall charge to end up 1 negative, because that's the charge of the manganese, I need to figure out what manganese charge has to be so that when I add the 8 negatives, I should end up with 1 negative, right? So it's just a little bit of quick math to go from 8 negative to 1 negative. That's going to be 7 positives, right? So if I look at 7 positive charges and I add 8 negative charges to it, I'm going to have an imbalance of 1 extra negative charge, and that's what my ion charge needs to be. So now I know that the manganese has to be a 7 plus charged ion. So now that I've identified what manganese charge has to be, if manganese is going from plus 7 and it's becoming 2 plus, I just need to figure out what that difference is between them. That's going to be how many electrons were added. So to go from 7 plus to 2 plus, right, we needed 5 electrons, right? 5 electrons have to get me to that number. So that's how I can determine what the number of electrons are in my reduction half reaction. So it's a little bit trickier there. It takes a little bit of work with that polyatomic ion, but the key is that we know what oxygen's charge should be. Oxygen's charge should be 2 negative. So we can work out what the charge of that manganese is in that permanganate ion. And once we've identified its charge, we can look and say, okay, it went from plus 7 to plus 2. Well, that's just a difference of 5. So there had to be 5 electrons involved, right? Now we've identified our 2 half reactions. We've got our cobalt half reaction. That's the oxidation one because it lost electrons. And the permanganate ion gained electrons to give us the Mn2 plus ion.